Good afternoon, everybody. I hope you're doing well. Hope you've had a chance to check out the other video I've put on the YouTube channel. And I hope that you're taking care of yourself. You're finding some time to get out and enjoy the weather when it's nice, or find some other ways to make it through this challenging time. So in the last class we were talking about biodiversity and this idea that the majority of species that have been described are animals, and of those, most insects. And then we talked about some of the reasons for preserving biodiversity. We talked about arguments of an economic nature, ecological nature, ethical, and even what we might call an aesthetic or spiritual nature. Right? So these are all reasons for why we would want to keep biodiversity as it is on Earth. So if we're convinced that losing species is bad, our next step is to think about what's causing it, right? So we're talking about biodiversity in our class largely because we have a problem with losing diversity. So this is when I'd ask you all to think about what could be causing species loss and come up with a couple examples. But there's really three main factors that are acknowledged across the globe. Those are introduced species, direct exploitation, and habitat destruction. And of those three, habitat destruction is really the biggest. So we're going to go ahead and talk about each of these separately, and I'll also share a little story of my time in Nepal. When we talked about evolution, we mentioned the cichlids of Lake Victoria and how it's amazing that there are so many species of just this one type of fish. This has really been an evolutionary puzzle. So like a lot of parts of the world, Lake Victoria in Africa suffered with degradation due to things like overfishing as the population grew, introduction of non-native species which could compete with the native species and then make it more difficult for them to survive, and also cultural eutrophication, which you'll remember from our discussion of nutrient cycles, what that is. Then in the middle of the 20th century, this showed up. This is the Nile perch. It's actually in the cichlid family, interestingly enough, but it's a huge predator, and it was introduced to have a commercial, different commercial species that could be harvested regularly from the lake, and it also became the basis of a sport fishery. But if you just look at the size of the mouth on that thing, you can imagine what kind of an impact it had on the native species there. It was pretty devastating. This is a graph of harvest of different types of species in Kenya from the late 60s on into the early 90s. And the darkest bars there are the haplochromines. Those are some of the native cichlids. Then the intermediate bars there are omina, which is a non-native species, but not one that seemed to impact the ecosystem in a major way. And then the light gray bars are the Nile perch. And so you can see it took a while for them to really get established. But by the time the late 80s came along, the majority of fish being harvested out of Lake Victoria were these Nile perch. So they really kind of took over the ecosystem. And you see hardly any of the native haplochromine cichlids being harvested at that point. To look at the native species biomass in the lake, you can again see this flipping from native species making up just about everything in the 70s to by the time the 90s came along, the lake was completely different. It was almost all these introduced Nile perch. So this is a concern, right? It certainly has led to the loss of lots of native species. In fact, by 1990, it's estimated that 80% of the native cichlids had been extirpated from Lake Victoria. Now, extirpated is a word that means locally extinct, so these species persisted in some other places, but in Lake Victoria, the species were, majority of them have been wiped out by the time the 90s rolled along. So some of you may have noticed the image that I have on my YouTube channel, which is right here. It's me holding a fish at the Fisheries Development Center where I worked in Nepal while I was in the Peace Corps. And it's kind of exciting because this is a large fish. A lot of the fish that we farmed in these ponds were quite a bit smaller, but It was kind of exciting when we saw one of these fish. So a lot of the time I spent in the Peace Corps, it's a very different office culture there, and that's a topic for another discussion. But there's a lot of time hanging out on the office, reading the newspaper, chatting, that kind of thing. But then another big piece of it was harvesting fish from these experimental ponds at the Fisheries Development Center, where we were testing different types of aquaculture and seeing what worked well. This is a picture of myself pulling a net there. And then I'd also travel out into the village and help farmers with their projects. So this is a picture where we were harvesting some fish from the village, and you can see some fish jumping over the net there. That's a fish called the silver carp, but some big fish that were harvested here. Well, back to this fish. So you might not be surprised to hear that when we find a fish this large in the pond, it's eaten a lot of the other fish. And what happened is we would fill these ponds with water from the local streams. And if that water happened to have some eggs of these wild fishes, they develop in the ponds, and they would eat all of the fish that we stocked in there. So when we harvested the snakehead, there were not too many native fish that were still remaining there, or cultured fish, stocked fish that still remained there in these ponds. But it was still kind of exciting to see a big fish. So this fish is actually, the common name in North America is snakehead. And if that name rings a bell, it's because they've now become established in North America, well outside of their native range. So this is a South Carolina Department of Natural Resources flyer encouraging fishermen, if they catch these snakeheads, not to release them back into the rivers and streams, to keep the fish and contact the state to let them know, because this is an invasive fish now that has had big impacts on native fishes, and it's eaten quite a bit of them. So this predator has become a problem in North America as well. Although I don't think it's quite as serious as they make it sound in this website. So far as I know, snakeheads cannot climb trees, but they can live out of water for quite a while because they have sort of a rudimentary lung. So if you've heard of a snakehead, that's what we were getting in Nepal. They're native to Nepal. All right. So invasive species are a problem. Non-native species are a problem and have led to a reduction of biodiversity in lots of different places. The next issue is direct exploitation, and I'll share an example for each of these. So direct exploitation is essentially over-harvest. And the best example of this we have is the passenger pigeon. So this is a stuffed passenger pigeon, image from a museum website. But a little bit about the story here. Passenger pigeons used to be, back in the late 19th century, so abundant in the American West that they said that when the flocks flew overhead, it would actually block out the sun. That's how abundant these birds were. But unfortunately, they were very easily harvested because they lived in these huge flocks, and when they would roost, when they would nest, it'd be giant flocks all together, and so they were very easily hunted. And there were a couple unfortunate technological advances that led to these species that led to the passenger pigeon being overharvested. The first was the development of the Transcontinental Railroad. So in the late 19th century, when the Transcontinental Railroad was finished, it meant that people could harvest as many of these passenger pigeons as they could shoot, because you didn't have to eat them immediately. You could put them on the train, ship them to places like Chicago where they would be eaten. So that increased the incentive to overharvest. The second, interestingly enough, was the telegraph. Right? So the telegraph in the mid-19th century was a way to communicate over long distances very, very quickly. And so people in different towns would let each other know, hey, the passenger pigeons are coming your way, get ready. And so because of that, there was a massive overharvest of this bird that used to darken the skies. In fact, the Native Americans used to say that passenger pigeons were so abundant that when their flocks were flying overhead, to harvest them, all you had to do was take a club and swing it when they were flying close to land. That's how abundant, how dense these birds were. So fast forward to the beginning of the 20th century, the last authenticated record of a wild passenger pigeon was in 1901, when a bird was killed and stuffed in Illinois. The last wild individual in Louisiana was found among a flock of mourning doves and other species, and shot as well. Now this is back before we had the idea of overharvesting species. In fact, there was a bill introduced to the Illinois state legislature to protect the passenger pigeon, but it wasn't taken seriously because people didn't even have the idea that we could hunt a species to extinction. It had never happened before. Well, toward the end, in the early 20th century, people did realize that, in fact, the passenger pigeon was going extinct. And so individuals were taken into captivity. And so it's an interesting example of a species that we know the exact date that it went extinct. Because by 1914, there was only one passenger pigeon still alive. His name was Martha. This is a photo of it on the right. And Martha died of old age on September 1st, 1914. So Aldo Leopold, who you may remember from our discussions of environmental ethics, had a really interesting essay he wrote. He entitled it "On a Monument to the Pigeon." This is a monument in Wisconsin, you can say, dedicated to the last Wisconsin passenger pigeon shot at Babcock, September 1899. The species became extinct through the avarice and thoughtlessness of man. And so I find this pretty powerful. So Leopold writes, this is in 1947, right? He writes, "Men still live who in their youth remember pigeons. Trees still live who in their youth were shaken by a living wind." That was what they called the wind of the wings of all these massive flocks of passenger pigeons. "But a few decades hence, only the oldest oaks will remember, and at long last, only the hills will know." Our grandfathers were less well-housed, well-fed, well-clothed than we are. The strivings by which they bettered their lot are also those which deprived us of pigeons. Perhaps we now grieve because we are not sure in our hearts that we have gained by the exchange. The gadgets of industry bring us more comforts than the pigeons did, but do they add as much to the glory of the spring? For one species to mourn the death of another is a new thing under the sun. The Cro-Magnon who slew the last mammoth thought only of steaks. The sportsman who shot the last pigeon thought only of his prowess. The sailor who clubbed the last auk thought of nothing at all. But we, who have lost our pigeons, mourn the loss. Had the funeral been ours, the pigeons would hardly have mourned us. In this fact, rather than in Mr. DuPont's nylons or Mr. Vannevar Bush's bombs, lies objective evidence of our superiority over the beasts. So I just appreciate how Leopold took this moment to realize that we as a species were memorializing another species and thinking about what we lost when that species went away. But maybe there's something to be said about human nature and our ability to be conscious of how we impact the environment, whereas other species are not. So that was kind of Leopold's point here, I think. All right. So the third and arguably the most powerful factor leading to species loss has been habitat destruction. And so another bird example here, the ivory-billed woodpecker. This is an actual photo of an ivory-billed woodpecker. And so these were birds that lived in the forest, and they were large birds. And the problem with that was that they needed a lot of land. So they used to have a wide range from Texas all the way up to North Carolina. But each breeding pair of birds needed 10 square miles of forest to be able to find enough food to feed their young and themselves. So in the 20th century, as deforestation was rampant, the habitat patches large enough to support these ivory-billed woodpeckers became more and more scarce. And so 1944 was when the last ivory-billed woodpecker was gone. There's an interesting story here too. Again, this kind of thing couldn't have happened in the age of the Endangered Species Act, but there was a logging company from Illinois that owned the rights to a patch of forest that held the last ivory-billed woodpeckers, and the governor of Louisiana, where that occurred, actually wrote to this logging company and said, that they were willing. Louisiana was willing to purchase that land from them to protect the ivory-billed woodpecker. But this logging company declined. That area was logged, and as it says, the last ivory-billed woodpecker was gone by 1944. So clearly species that are high up on the food web that need lots of land are the ones most likely to be greatly affected by habitat destruction. But this is really the factor that has led to extinction of more species than any other. And habitat destruction continues to impact and threaten more species than any single factor. Okay. So let's think a little bit historically about this idea of species and endangered and extinct. So endangered is a legal term. It refers to species that are at imminent risk of going extinct. And of course, extinct means that they no longer occur on Earth. But thinking big picture, it's so interesting, right? So almost all the species that have ever lived are now extinct, right? We can learn that from the fossil record. So throughout history, right, there's this trajectory of species coming on to the scene, then eventually going extinct. This has to do with what we call the background rate of extinction, that there are always sort of natural processes that lead to extinction for a variety of reasons. And a lot of these are climatic variables, for instance, that change on the time scale of thousands of years. So these are natural extinctions. They happen for all sorts of reasons. And it's just been estimated that there's one extinction per 1 to 10 million species from mammals and some marine species, and that about 1 out of every 1,000 of those species would go extinct every 1,000 to 10,000 years. So this background rate of extinction is pretty slow, and of course the reason that almost all species that have ever lived are now extinct is just because there's so much time involved, right? But 1 out of 1,000 mammal species going extinct every 1 to 10,000 years is not a very high rate of extinction. But then we have these mass extinctions which occur through time, and that's a different scenario. So in the past, 500 million years or so, mass extinctions, there have been 5 mass extinctions that have eliminated at least half of all species. And so this is based on our data from the fossil record. But what's interesting is that after each of these mass extinction events, biodiversity returned to or exceeded the number that were there before the extinction event. So the cartoon on the bottom, again, is looking over the last 500-600 millions of years. And these are data from the marine fossil record, right? These are the number of families, right? So families are groups of similar species. So you can see, this is again based on fossil data, there are these 5 events where there's a pretty sharp drop that leads to loss of many species. And we might know the most about the most recent one, the Cretaceous Tertiary extinction. If that rings a bell, that's the time when the dinosaurs went extinct, so about 65-70 million years ago. That was the time of this massive asteroid impact on the Yucatan Peninsula in what's now Mexico that led to cooling of the overall climate, and then so dinosaurs that needed to keep their bodies warm didn't make it through that disturbance. But after that was the time of the mammals, right? The mammals then came in and filled in the niche, if you will, where the dinosaurs had been, all those different niches. So if we look at extinction rates recently, they've been accelerating. This is an interesting paper that looked at the percentage of species that have gone extinct from species that are cataloged by the IUCN, the International Union for the Conservation of Nature. And really what it shows is, first of all, we have time periods from the 16th century up to the 20th century. And that dotted line is a background rate of extinction. So that's that natural rate that, is going on no matter what. But then we look at rates of extinction for vertebrates as a whole in that green line, and we can see clearly, right, that the number of extinctions has been accelerating, in particular since the 19th century. If we look at mammals as a whole, we can see that their extinction rates have been higher even since the 16th century. Then birds have just accelerated recently. So the point that this article was trying to make is that extinctions have been increasing. And so it's argued that we're now moving into an additional mass extinction event. But this one differing from other mass extinctions in that humans are playing a large role here. So if we look around the world at some of the extinctions, particularly of mammals and birds, what we see is that humans have played a pretty large role, right? So in North America, almost 3/4 of large mammals went extinct. Now, this was not long after the Ice Age. So some of these animals had populations that were depressed by the climatic change already. But then, again, the last Ice Age is the estimated time when lots of people migrated to North America from Eurasia, because there was this land bridge between between Alaska and Siberia, right? That so in the last Ice Age there was a lot more global water locked up in ice, so that lowered sea levels, and that exposed this land bridge between North America and Asia, and so that's when the largest amounts of people came to North America, and it was not long after that these large mammals disappeared. In fact, there have been studies that have shown that mammals persisted longer on islands that people did not colonize. So it does appear that hunting was partly responsible for these extinctions in North America. So in New Zealand, as humans colonized islands, there were species of birds like moas, which are flightless birds, and they went extinct about 1,000 years ago as people made it there. So it's important to note that humans are playing a larger and larger role in the affairs of the planet, and that certainly includes extinction events. So, I don't want to paint a picture of all doom and gloom here. I do think it's important to notice that we have done a lot to try and stem extinctions. So we have this classification scheme where we can nominate species for protection. So this is a picture of a salamander called the eastern hellbender. These are a couple of my research students from, I think it was around 2012. And this is the Little River, which flows through DuPont State Forest, so land that's protected at the state level. And because these lands have been protected, the habitat has been protected. So because of that, the eastern hellbender is a species that it's not doing very well, but here in the mountains of North Carolina, it's doing great. So we do have some success stories as well, and I think it speaks to Leopold's assertion. Maybe one of the greatest evidences of human ingenuity is our awareness of our impact on other species, and in many cases, our preventing extinction through proactive measures. So the eastern hellbender is still here, as are lots and lots of other species. So I think it's important that we learn from seeing these impacts that we have on species, and do everything that we can to preserve biodiversity moving forward, because of all the reasons that biodiversity is important to us that were highlighted in the last lecture. So I hope you all are doing well. I hope to see you at our class Google Hangouts today. But if not, feel free to reach out through any other means and to get in touch with me if you'd like to talk about course-related content, any other questions, or if you have any specific questions about this lecture. And I hope to see you all soon.